Okay, finally got the notes back up. All right, so this is where we left off, and we were looking at this, and we could see these big chunks of color. These were all crystals. Big chunk of black crystal, white crystal, pink crystal, gray crystal, large crystals, slow speed. So again, what is this, magma or lava? If it's slow, it's magma. Now, why would it cool slow in the ground? Why does it cool fast above the ground? Well, what do we have above the ground? We have cold air, we have cold water. So things are going to cool faster above ground. In the ground, you have magma, you have heat, you have the core of the earth, which is thousands of degrees. So yeah, it will cool slower in the ground. And the slower it cools, the bigger these chunks and the bigger these crystals are. So this is magma and it is intrusive. It's the only one out of all these that are magma and intrusive. This you can see is somewhat like grains of sand-like appearance. And if you have the grains of sand-like appearance, like crystals, those are small. So the cooling speed is what we consider fast. Again, lava, extrusive. And then we have no crystals, no crystals. And this is, oops, get rid of that. I don't know why that's staying on there. Okay, I'm sorry. um, So no crystals, that means extremely fast in both cases. And this would be extrusive. Okay, so that is the part from the notes. Hopefully that helps you. Sorry, my hair's dry. Okay, so let's go back to the presentation and talk about classifying the notes. And this is actually, if you want to go on to the next page of notes here, I gave you really good examples. And the same four rocks are right there, and talk about the different textures. Okay, so the different textures, what do we call big blotches? They don't call that in science. They call them coarse. That is a coarse-grained rock where you see the large blotches of colors. If you see the small light grains, we call it fine. Okay, so fine is small crystals, coarse would be large crystals. And then you have glassy, and you have glass. Well, it literally does feel just like a piece of glass, like black glass. If anybody knows that rock, it's called obsidian. And then vesicular, where you see gas particles trapped inside. So look at your notes again here, the large blotches, right? If you want to get in close on that. And then you see, why aren't we? There we go. Then we see the small grains right there. You see the glassy appearance. And then you see the actual gas pockets trapped inside. So that's vesicular. So again, that's coarse, that's fine, that's glassy, and that would be vesicular. And you're going to fill those all in right there. Okay, so those are your four textures. And again, please, if they're asking for textures with rocks, we're not talking about rough or smooth or anything like that. Okay, so the other way, now we start off with igneous rocks because they're probably the most complicated. It's definitely the most complicated of the three reference tables, and there's a lot more to it than the other rocks. The other way you can classify igneous rocks is by their color, their density, and their composition. And we divide these up into two groups of rocks. We call them felsic rocks or mafic rocks. Okay, so we'll start off with felsic rocks. So felsic rocks are lighter colored, they're very low density, and they are made of aluminum and silicon. Now, if you ever had any kind of outdoor tools made of aluminum, you ever pick up an aluminum rake? It's very light. It's a light colored metal. It's a very light, physically light to lift type tool. Those are felsic. So they're lighter colored and low density. So it's a lighter colored and made because of these lighter elements like aluminum and silicon. Now the mafic rocks, these are darker and they're high density. And these are made of iron and magnesium. If you ever had an iron shovel or an iron rake, these are very heavy because they're very dense metals. Iron is a dark colored mineral, so it makes these rocks a very dark colored. So you have felsic rocks, which are light and low density, and you have mafic rocks, which are dark and high density. And again, going into your notes, that would be right here. Okay, so again, you have felsic, light colored, low density, made of aluminum and silicon. Then mafic rocks that are dark colored, high density, made of iron and magnesium. Okay, so Now, something else that this is usually where the only place you're going to see this next statement is on the lab practical, and that is how do you know? Okay, so they're asking you, you know this is an igneous rock. Give me proof that you're looking at a coarse-grained rock. Okay, so that is this right here. You're not going to see too much of it on the quiz or test now, but put big stars next to this on your notes. Where you see it in quotes on the notes, proof you're looking at igneous rocks, fine or coarse only. You say you're looking at that one with the big blocks of color. You know it's an igneous rock. Prove it. What do you see? You see something called intergrown crystals. You can't say I see a coarse texture because you can also use coarse to describe a metamorphic rock. So you're going to say I see intergrown crystals. Very important, not for now, but for at a later date when we start talking about the lab practical. Now, there are also some rocks where you see both fine and coarse, like right here. You see this big chunk. That's a big crystal. Then you see a bunch of little ones. Okay, these rocks very rarely are asked about on the Regents, but those are called porphyritic rocks. So they have both fine and coarse. And I ask you, you PBL people, project-based learning, how could this have happened? Normally, I'd give you a few minutes to think about it. You could pause it if you want to try to come up with the answer. But the answer is it started off cooling off slow, but then it, for whatever reason, picked up speed cooling off. So it started off slow, making the slow crystals, and then maybe it was risen to the surface, and then the cooling sped up, and then it made the smaller crystals. Okay, so now let's show you the reference table and show you it's not, like I said, it's not a mess. It's just, compared to the other ones, it's a little bit more involved here. Okay, so this is the reference table right here. You know what? There we go. There it is right there. And let me see if I can get my face out of here. So, my face. There's no good place to put myself. There we go. Over there. Okay, so igneous rocks, this is one of the reference tables. And you could see here some of these terms. You have intrusive, extrusive. So when you say intrusive, that means all these rocks right here are intrusive. Now, sometimes you'll also see that term plutonic. So please, if you ever see plutonic or volcanic, please know that is written here on the reference table, and you don't have to memorize that. All these rocks, granite, pegmatite, diorite, gabbro, periodotite, dunite, these are all intrusive. And notice their textures, coarse and very coarse, meaning that their crystals are very large, again, because they cooled in the ground, so that means they were cooled very, very slowly. Now, the other rocks we have here, we have our extrusives. Okay, so let's see if I can make that. All right, so extrusives are these guys. Okay, so anything in this box is cooled above the ground and is also called volcanic. All right, so everything on this page. And notice the textures again here on the right. The textures for extrusive rocks are glassy, fine, and vesicular. And if you're looking specifically for the fine-grained rocks, then that would be, you look here. Here's fine. All these guys have a fine texture. Honestly, the only ones that are vesicular are pumice and scoria, and the ones that are glassy are going to be obsidian and basaltic glass. Okay, so that's part of this here. Now, the other part of this reference table, I guess I'm so used to just being able to click a button and erase everything here. I don't know how to do that. Sorry. I'm sure there's a way. So the other part of this reference table is the bottom. And the bottom is not, let's go back to pointer. No. Okay. I'm stuck on eraser. Okay, so the bottom shows you where, there we are. Okay. Where the felsic and the mafic rocks are. There they are. And you can see here, felsic are all the rocks on the left side, and mafic rocks are all the ones on the right side. So when you look at the reference table, all these rocks here will be dark, made of iron, very high dense, and all these rocks over here will be lighter, lower density, and felsic, made of aluminum and silicon over here, iron and magnesium over here. All right, I'm going to come back. We'll talk some more.